Before beginning this section, you should review the Introduction to Hypothesis Testing About Means section. Here, we will discuss a few examples of hypothesis testing about means where sigma is unknown. Recall back in our confidence interval section when we first encountered the t-distribution. When sigma is unknown, S, our sample standard deviation, must be used to estimate sigma. In this case, we use the t-distribution instead of the z standard normal distribution. For a large sample case with sigma unknown, or a small sample case with a normal population and sigma unknown, the test statistic and rejection rules for our three basic hypotheses about means forms are listed here on this slide. In our confidence interval section, we learned how to compute T alpha over 2. So T alpha should be the only unfamiliar measure on this slide. Here we have steps for computing T alpha. In step 1, we state our upper tail area as alpha. In step 2, we compute our degrees of freedom as n minus 1. And in step 3, we go to our t-chart and find the t-value with the upper tail area stated in step 1 and the degrees of freedom computed in step 2. This is our T alpha value. Here, we recall our steps for computing T alpha over 2. Since we have already had some practice with hypothesis tests about means, let's dive directly into an example. Golden Oats Cereal Manufacturing Company monitors its bagging equipment to make sure the machine is working properly. When the machine is properly working, it fills 16-ounce bags of cereal. A sample of 30 bags had a mean weight of 16.5 ounces and a standard deviation of 1.5 ounces. Set up a hypothesis test to determine if there is a problem with the bagging equipment. Use alpha equals 0.05. First, we should note that this is a large sample case since n, our sample size, is equal to 30. Next, since this problem only states that the standard deviation is 1.5, we should assume that this is the sample standard deviation and sigma is not known. Had this standard deviation value been the population standard deviation, the problem would have stated that the population standard deviation is 1.5, or it would have said sigma was equal to 1.5. Since there was no indication that this was population standard deviation, we assume that this is the sample standard deviation, S. In step 1, we list our hypotheses for this problem. Our null hypothesis is the mean weight is equal to 16 and the machine is working properly. Our alternative hypothesis is the mean weight is not 16 and the machine is not working properly. In step 2, we should go out and collect a sample of items in order to test our hypotheses. We should also list our sample size, which is n equals 30, and our level of significance, which is alpha equals 0.05. In step 3, we should research to find the appropriate test statistic and rejection rule for our scenario. Before beginning our research, we should note our null hypothesis, which is the population mean equals 16, our sample size, which is n equals 30, and any information that we know about the population. For this problem, the population standard deviation was not given, therefore sigma is unknown. For our problem, we have a large sample case since n is equal to 30 and sigma is unknown. Therefore, the test statistic and rejection rule that we need is given on this slide. Since our null hypothesis is the mean is equal to 16, this third box gives the null hypothesis, which is similar to ours. The test statistic and rejection rule written in this box should be used for our problem. In step 4, we state our test statistic, and in step 5, we state our rejection rule. We should specify our critical value T alpha over 2. For this problem, since alpha is equal to 0.05, our upper tail area is 0.025, and our n value is equal to 30, therefore our degrees of freedom is 29. So if we follow our steps for computing T alpha over 2, we should go to the T distribution chart and look for an upper tail area of 0.025 and 29 degrees of freedom. If we do this, we will find that our T alpha over 2 value is equal to 2.045. In step 6, we should plug in our values into the test statistic. We plug in our x-bar value, which is 16.5, our mu0 value, which is the value listed in our hypotheses, our S value, our sample standard deviation, and our n value. In step 7, we should apply our rejection rule. Our rejection rule told us to reject H0 if the absolute value of T is greater than or equal to 2.045. Since our test statistic value 1.83 is not greater than or equal to 2.045, we do not reject H0. Since we were unable to reject H0, this means that we did not have sufficient evidence to prove that HA is true. Therefore, we did not have sufficient evidence to prove that the mean weight is not equal to 16 and the machine is not working properly. Example 8. A new hybrid vehicle manufacturer claims to get at least 40 miles per gallon on the highway. A sample of 16 vehicles shows a mean miles per gallon of 42 with a standard deviation of 3.2. Use the sample of vehicle miles per gallon to set up a hypothesis test to prove the company's claim. Assume that miles per gallon is normally distributed. Use alpha equals 0.05 to test this hypothesis. In step 1, we state our hypotheses. Since we are trying to prove that the mean miles per gallon is at least 40, we should state this claim as our alternative hypothesis. If our alternative is the mean is at least 40, then our null is the mean is less than 40. In step 2, we're supposed to go out and randomly select a sample to test our hypotheses and state our sample size, which is n equals 16, and our level of significance, which is 0.05. In step 3, we should go out and research the appropriate test statistic and rejection rule for our scenario. Before doing this research, we should note our null hypothesis, which is the population mean is less than 40, our sample size, which is n equals 16, and any information that we know about the population. For this problem, since the population standard deviation was not given, we have to assume that sigma is unknown. Whenever you have a small sample case with n less than 30, you should always go back to the original problem and make sure that the population is normally distributed. Remember, for a small sample case, we must know that the population is normally distributed in order to apply the formulas. For our problem, we have a small sample case since n equals 16. The population is normally distributed and sigma is unknown. Therefore, this slide contains the test statistic and rejection rule for our problem. Since our null hypothesis is the population mean is less than 40, this second box is similar to our null hypothesis. So we should use the test statistic and rejection rule stated in this box for our problem. In step 4, we write down our test statistic, and in step 5, we write down our rejection rule. We should always list our critical value for the rejection rule. If we follow our steps for computing T alpha, not T alpha over 2, but the steps for computing T alpha, our upper tail area should be equal to alpha, which is 0.05, and our degrees of freedom for this problem is 15, which is n minus 1. If we go to the t-distribution chart and look up an upper tail area of 0.05 and 15 degrees of freedom, we will find a T alpha value of 1.753. In step 6, we compute the value of our test statistic. Here, we plug in the value of x bar, which is 42, our mu0 value, which is the value listed in our hypotheses, our standard deviation value, which is 3.2, and our n value. If we do this, we will compute our test statistic as 2.5. In step 7, we're supposed to use the value of our test statistic and our rejection rule to decide if we should reject H0. Our rejection rule told us to reject H0 if our test statistic value is greater than 1.753. Since our test statistic value, which is 2.5, is greater than 1.753, we should reject the null hypothesis. Recall that rejecting the null hypothesis means that we have proven the alternative to be true. Therefore, we can state that we have found significant evidence to prove that the mean miles per gallon for this vehicle is at least 40.